Всем добрый день. Меня зовут Санат, и сегодня я бы хотел...
Hi everyone, my name is Sanat, and I'd like to share with you my experience of devirtualizing a KoiVM-protected object. Just a few words about myself. For the past 5 years, I've been analyzing malicious code, and while previously I analyzed malware used to attack public institutions, recently I started analyzing malware attacking large and medium enterprises. As for my subjective opinion, the differences are shown in a slide. The public sector is shown on the left-hand side, and the attackers who attack the public, the goal is for attackers is document theft, and they try to steal everything they can. So it's industrial espionage, and their technical priority is obfuscation. They never use dirty hacking. They seldom use bulky protectors because they don't want antiviruses to track them down. And deployed functionality. We saw huge taskbar functions that could process several dozen commands and download plugins. While in the private sector, attackers might have different goals. They can vary a lot. They are ready to be detected. They try to penetrate as fast as possible. They obfuscate their code. But unfortunately for the viral analysts, after the heavy protection is removed, the payload dropped is quite limited in terms of functionality. And I'd like to give you a specific case to justify my last thought. I received OLE2 XLSX object. It contained an encrypted packet, and the usually Excel asks for a password if a file is encrypted, but this encrypted packet was had a hard-coded password, and this technique allows the attackers to conceal against to hide so that they are not automatically detected. This packet contained an OLE object that used this CV exploit, and it had a shell code that acted as a loader. It loaded the vbc.exe file from the attacker's database. But this file was not stored in this server. However, open source intelligence helped me find a research of this file in the AnyRun sandbox, and if you register, you can download any file for research. vbc.exe is a malicious program with a memory dropper functionality. It decrypts the KoiVM file. The KoiVM is a plugin for the confuser protector. It used to be, starting from 2020, its source code is available on GitHub, while previously you had to pay for it. The source code is transformed into a chain of virtual commands. And the user code request looks like this. The decompilator has a thread of Koi with the fish signature, and the fourth thread shows the number of virtualized functions. If you drop below, you'll see a table of virtual functions showing ID, offset with regards to the Koi thread, and the key for decrypting the first byte. As for the decryption algorithm, first we read the first byte, and then we write it as the first operator. Then you multiply the key by 7, and you add the previous byte. Then you read the next byte and you complete the very same operation, but the result is not going to be written as an operator, but rather is designed to modify the key. And depending on the operator, we decrypt the operand.
Строки и в целом, чтобы расстроить все строки.
To decrypt all the lines, you need just a simple script. However, if you want to translate it into common language, you need a devirtualizer. You can find the old rot utility on GitHub, and it helps you to devirtualize objects that were virtualized by source KoiVM and modified KoiVM.
В данном случае
In this particular case, the first modification
виртуальных константов
was for the virtual constants, and this file lists 119 constants split into 7 groups.
Которым присваивается значение от 0 до 250.
And they have a value of 0 to 255, and they are never repeated. While the source KoiVM, well, if the source KoiVM had initializers with the constant values inside,
В данном случае этот инициализатор был обфусцирован.
well, in our case, the initiator was obfuscated, so we couldn't run the statistics analysis. You can bypass that in two ways: either debug the code stage by stage, or put the dot, collect the dump, go to Visual Studio, and then analyze the dump to identify, well, and you can just use the cursor to see what the constant values are. After calculating the constant values, we need to deep dive into the functionality of these constants. We need to see the implementation functions in the source code and align them with the malicious code. Therefore, we can identify the constant values of the opcodes and VM codes groups. Constants from other groups don't have their own implementation functions, and you will not see them either in the malicious code or the chain of commands. You can only translate them by using their execution scenarios. There are constants that can be initiated by they will not be found in either the source or the virtual machine. To populate them, we need to use the unused names of the constants. When we compare all the constants, we get this table split into 7 groups, and we need to convert it into the JSON file and then send it to the old rot devirtualizer. However, when I tried to devirtualize it, I came across another bug. This is the type inconsistency error. And to debug it, you need to debug the old rot in such a way as to bypass all the exceptions in the virtual machine. We're interested in the call and vcall functions that store the function execution data. This slide shows the attachment value stores the pointer to these functions. After the devirtualization, we get this type of code. Shown on top is the original file, and shown below is the devirtualized file of the malicious code. Then we can identify the function. This file was the full-scale execution environment check. It also unpacked 2 legitimate utilities that were used for execution environment check. One of the files was sent to the memory, and this process was selected randomly. Every time you run it, the process is going to be different. The payload in this particular case is the Xloader 2.6. It features the functionality of a keyboard spy. It can steal data from the Buffer, it could act as a loader, and it can reboot your desktop. Another interesting thing is that the payload can conceal domain addresses, and it's worth mentioning that VBC.exe was analyzed, and one of the sandboxes managed to bypass all the anti-analysis checks. It was able to decrypt all the domain addresses and put them in a list. This sandbox used domain names search rules for all the versions, so it did not find two other domain names. And the malware used the old database as a common database for CNC, because in the previous version it was only used for listing fake names or honeypot names. Thank you so much. If you have any questions, you'll be able to address them to me later on.